Hello. Now we are going to see a problem in physics useful for NEET and JEE exams. The topic is magnetic field at the center of a square loop. We will take up a problem. See, this is the problem. A conducting loop is in the shape of a square of side A equal to 40 centimeter and carries a current of I 10 ampere as shown in the figure. Calculate the magnetic field and give its direction at the center of the square. If this conductor is reshaped to form a circular loop and carries the same current, what is the value of the magnetic field at the center? So diagram is given. This is the diagram. Obviously it's a square, carries a current of 10 ampere and the side of the square is 40 centimeter. Of course, when you convert it into meter, it will become 0.4 meter. What you are supposed to find? Magnetic field at the center of the square, both in magnitude and direction. That is subdivision A. What is subdivision B? Imagine this square conductor, a conducting loop is now changed into a circular loop. Then what will be the magnetic field at the center of the circle? That is the question. Okay. Now we will go to the solution. This is the conductor. Suppose if you have a conductor, thin conductor of finite length, then magnetic field, let's say this carries a current I, then the magnetic field is given by a different formula, not mu naught I by 2 pi r. So you may be familiar with the formula magnetic field due to a straight conductor B equal to mu naught I by 2 pi r, but that is applicable only when the conductor is of infinite length. For finite length, how to write the expression for the magnetic field? Derivation I am not going to give, I just give the expression for the magnetic field produced by a conductor of finite length. Say this is a conductor of finite length. The conductor one end is here, the other end is here. The conductor carries a current I, and this is the point P under consideration. We want to find magnetic field at P. So join the ends of the conductor to the point P and also draw a perpendicular from P to the conductor. Now call the angles as alpha and beta. Alpha and beta. What is R? R is the distance to the point P from the conductor. So alpha and beta, alpha plus beta together is the angle subtended by the ends of the conductor at P. With respect to the perpendicular line from P to the conductor, one angle is alpha, other angle is beta as shown in the picture. Okay, there is a formula now. I just give the formula. I am not going to derive the formula, which is not required here. So what is the formula? The magnetic field at P is given as, note that it is a finite length conductor. B is equal to mu naught I by 4 pi r sin alpha plus sin beta into sin alpha plus sin beta. Mu naught I by 4 pi r. Mu naught, of course, you should be knowing permeability of free space, whose value is 4 pi 10 power minus 7 Tesla meter per ampere. I is the current and R is the distance to the point from the conductor. Alpha and beta are the angles shown here. We will use this formula to solve the current problem. Now what do? Find the magnetic field due to one side of the square at its center, then multiply by 4. This magnetic field produced by all these 4 conductors forming a square being in the same direction. Net magnetic field is magnetic field due to one side, current in one side, multiplied by 4. Okay, this is the 10 ampere given in the data. Let's say AC is the conductor. So find at the center of the square the magnetic field due to AC and then multiply by 4, because the situation is very symmetric and also direction of the magnetic field is same. So it's enough if we find magnetic field due to one side. We are taking AC as that side, and to find that magnetic field we are going to use this formula. Say this is the center of the square. Distance of the center of the square from the conductor you can easily find. This is the distance of the center of the square from the conductor under consideration is this, and call this angle as alpha, but that should be 45 degree, this being the square. The other angle is also 45. So alpha is 45, beta is 45. What about this distance of the center of the square from the conductor? That is 20 centimeter, because side of the square given 40, so it should be half of that, so 20 centimeter. Now you can use this formula. Understand that mu naught I is 10, R is 0.2 meter, alpha 45, beta 45. Substitute 4 into this, because this is only for one conductor AC, multiply by 4. So 4 into mu naught I is 10, 4 pi r is 20 centimeter converted into meter, gives you 0.2 meter. Then sin 45 plus sin 45, because sin alpha plus sin beta. Substitute the value, simplify, you will get the answer as 28.3 micro Tesla. Magnetic field at the center, 28.3 micro Tesla. Of course, it will be into the plane of the diagram. Using right hand rule, you can easily find that the magnetic field at the center of the square will be into the plane of the diagram. Have you understood that? Now we will go to part B. When you reshape the conductor into a circle, then circumference of the circle will be equal to perimeter of the square. That is 2 pi r equal to 4a. What is capital R? Radius of the circle into which the square loop is reshaped into. Okay, to which the square loop is reshaped. So 2 pi r is equal to 4a. A is the side of the square, from which you get r is equal to 4a by 2 pi. A given to be 40 centimeter, convert into meter, which is 0.4, 2 pi as it is. So when you simplify this, you are getting 0.254 as a radius of the circular loop. And we know the formula B is mu naught I by 2r. So I is 10, mu naught as it is 2 into r. Of course, there should be a 2 here. So 2 into r. This is given r, 2 into r. So you imagine, you just take one 2 here, 2 into this. On simplification, you will get this as 24.7 micro Tesla. Once again, I say there is a correction here, 2r, but what is given here is only r. So you multiply this denominator by 2, then simplify, then this is the correct answer. So what is given here is only r, because you see this, but what you want here is 2r. Please make this correction. Okay, then final answer will be 24.7 micro Tesla, for which here there should be one 2 included. 2 into 0.254, that is only equal to 24.7 micro Tesla. Here it is correctly given, here that 2 has been left out, but you please include it when you do the calculation. Okay, 24.7 micro Tesla. That is the magnetic field in the center of a circular loop, if the square loop is reshaped into that circular loop. So what is the answer? This is also direction is into the plane of the diagram. Answer is 28.3 micro Tesla at the center of the square loop into the plane. Then again 24.7 micro Tesla if it is reshaped into circular one. That is also into the plane of the diagram. Is it okay? Thank you. Please like and subscribe. Thank you once again.